When you think of the domain, what do you think of?
The x value.
The x value where the function exists, right? So think of it like it's an x value where I could like plug it into the function and get a y value, right? If it doesn't exist, then if I tried plugging it in, I won't get anything, right? So for these three, the black function, blue function, green function, we have certain x values that either could or maybe could not be plugged in. So for the black function, notice how we're dividing. What can we not divide by? What's the number that you can never divide by?
0.
0. So if there's an x value that would force you to divide by 0, guess what?
Not right.
Not in the domain. Guess what? What is the domain though? Anything else? So we always assume domain is all real numbers. So we always assume the domain to be negative infinity to infinity, unless you can come up with a reason why it's not that, right? So for this one, we got a good reason why it's not. X can't be what?
0. Okay.
Well, if I plugged in 0, what would we end up dividing by? 5.
So it can't be 5. Negative.
So it can't be negative 5.
Oh, and then we just say
X cannot equal negative 5. So our domain is every number set negative 5. How do we say that?
all real numbers but negative 5.
You could say that. How about an interval notation? Think about this for a second. If this was negative 5 right here, and I put an open circle there, and I got everything else to the right of that, everything else to the left of that.
Oh, so would you like x is greater than negative 5 and less than negative 5?
Okay, you could say that.
Like,
how about this? Negative infinity to negative 5. That's this part, right?
negative 5 infinity.
And then union negative 5 to infinity. That's how you do it every time. Know the pattern. Okay. Now, if you forget how to write that, what should you say?
Negative 5.
There you go. Yeah.
Why did I think that was so hard?
All right. How about the blue function? Anything weird about that? Is there any sort of x that I couldn't plug in that creates a problem for me? So what does that mean?
All real numbers.
All real numbers. Boom. How about the green one? What's up with square roots?
Well, you can't square root negative.
You can't square root a negative. Okay, so that creates an issue for us, right? So whenever I plug in for x, the stuff inside the square root must be greater than or equal to 0, right? So we say, all right, 3x minus 3 has to be greater than or equal to 0. If we solve this, it'll tell us what x is. We'll make that true. So we add 3x is greater than or equal to 3, divided by 3. X is greater than or equal to 1. How do I write that in interval notation?
1 comma infinity.
1 comma infinity. With a bracket on the 1. Boom. Not bad, right?
I don't know
So,
why that's so much harder than it was.
in general, assume it's this, unless you can think of a reason that it's not. Guess what the only two reasons that are going to appear on the test? Denominators and square roots. All right.